Hey, welcome back. It's True again with another Cafe Yocto episode featuring the phyCORE-AM62x SOM Module and Development Kit. Before we get into today's specific topic, I want to recap actually our last episode over here in this tab. If you recall, we installed the SDK and that gave us access to the cross-compilation toolchain. We used that to cross-compile the Linux kernel, but before we did that, we made some modifications there in the standalone kernel development environment. Let's take a look at those changes. We can review those with git diff since I haven't actually committed any of these changes. What we did was we gave user LED 0, we overrode that device node and gave it a new name or label. And then we also changed that default on state at power on to a default trigger with a heartbeat. So it should blink with the heartbeat pattern. We took a look at that last time. Here it is, still booted up. So here at the tip of my finger. Now, in that process that we did last time, it required us to compile this new DTB and then swap it into our boot media such that it would take effect on the next boot. Now, that doesn't really work in a production setting, right? We would want to have our software good to go the first time and manufacture and flash it once during manufacturing and then have our system good to go out in the field. You wouldn't want to have a user have to intervene, halt the system, reboot it, move files around especially. You want to avoid all of that. So how do we take this change, this modification that we've made here in the standalone kernel development environment and incorporate it back into the BSP that we built together in the Build the BSP guide? Well, the first step is we're going to have to export the changes. And we can do that with git diff again. I misspelled it, but git diff, and then we just send that output out to a file that is descriptive of the changes that we're making, and I just give it a .patch file extension. And now we can see that our git diff output is left directly in here. So actually, what's cool is if I remove these changes, check this out. So now I shouldn't have any changes. I basically gotten rid of this. I can apply this patch manually like so, and now my changes are present again. So that's one really convenient thing about these patch files, and the Yocto project will enable us to incorporate them into a meta layer real quick, very easily. So that brings us to our topic of today's video, the creation of custom meta layers to essentially modify and change things in the underlying BSP so we can add these modular meta layers that apply changes on top of everything. So now that we have my heartbeat.patch here handy, imagine that I transfer that over to my remote build server. Okay, so now let's take a real quick detour at our deployed binaries. So recall that this .wic.xz, this is a compressed disk image. So it's going to define a partition table. It'll define the files that go in the boot partition as well as the root file system partition. So really, this file kind of contains all the other files you see in this directory. So this deploy directory deploys all the individual components, but also the complete disk image, which is this guy. Essentially, we want to have our change here from our standalone kernel development modification. We want that to be present in the default DTB that's also deployed here, but we also want it to be present here, not in just this, but also in our disk image. So in both places. We're going to talk about that today. So where's the best place to start to writing a meta layer? Well, remember that the default meta layers can be found here in sources. So we got meta phytech, including this provides all the bootloader recipes, the Linux kernel recipes. Meta Qt5 is providing the graphics. So meta layers are organizing the recipes. We're going to have to make a meta layer specific to our application. So what would I want to name it? Maybe if I'm making a smart fridge line, I'd want to do smart fridge, meta smart fridge. Let's go ahead and just do some example. And the best way to start is pick layers, create layer, and then the path and name of our meta layer. I like meta example, but again, if this is a line of smart fridges, you want to pick something appropriate. So I'm just going to go with meta example for now. And essentially what we can do with this bitbake layers create layer is we can create a skeleton or a template, if you will, that we can then just fill out. And it makes it a lot easier to start writing or start incorporating changes into a Yocto-based BSP. So taking a look at meta example, we have a number of files and directories already created for us. So some of the key ones, just kind of give us a quick tour. So the layer.conf, this is going to specify the layer compatibility. So this meta layer is compatible with Dunfell. This is set up in a way that it should just work because we utilize bitbake to make it. So that's why I also recommend starting from that point and using it as like a template. This priority is interesting, just a quick mention. In the case that two meta layers are providing the same recipe for the same package, I believe it's this meta layer priority that would then have the meta layer with the higher priority take precedence, and that recipe would get used. So this would resolve conflicts such as that. But anyway, for the most part, you don't have to touch this file unless you're porting your meta layer to a future Yocto BSP from phytech. If you're kind of keeping up with our latest software, you might need to tweak this file just to maintain the compatibility. And as you do that too, you'll also have to potentially modify the syntax of your recipes and things like this to kind of keep up with those changes from the Yocto project. So we talked about a little bit about layer.conf. The really juicy bits are here in recipes example. So recipes dash package name, this is the convention. So you could have multiple recipes, recipe dash examples in any given meta layer. What I'm trying to say is any meta layer can provide multiple recipes. If we navigate in here, you can see that there's only one directory example for this example package. Now, that's because the dependencies for example is just itself, but you might have more dependencies, right? Like you might have example 1, example 2, example 3, all being dependencies of recipes example. So this is, again, it's a very simple template, and it's just to explain where this redundancy of naming seems to come, because it is kind of strange when you first start, but there's a reason. So let's navigate further, and now we're looking at the actual recipe. So the recipe is going to say the package name by convention, then the version for that software, and then .bb just means recipe. This is a recipe file. Let's take a quick look at that. Oops. Now, there's not a whole lot of exciting stuff going on in here. In this case, we're just specifying this task that's going to print this like asterisk block. It's going to do that before the do build step. What this is saying, essentially, this is an example of us defining our own tasks. Some of the some of the ones inherited from these what are called bitbake classes, BB classes. It's kind of functionality inherited from the Open Embedded, which is the build system that's actually active in the Yocto project. We can queue up custom tasks, overwrite tasks, and we can change the order of them here, all in these recipes. So that's just a quick example of how we generate a framework or a template, and then you could compare this to some of the existing meta layers. For example, Meta phytech or Meta Arago. There's a lot of user space utilities included in these, and you could just take a look at examples and then, or take a look at them as references, and then modify this example meta layer to reflect and do whatever you'd like. Now, I'm not going to walk through that process. It'll take a little bit of time. So what I'm going to do is I'm going to just totally get rid of meta example, and I'm going to git clone my meta heartbeat meta layer. I do have this already public as well, so this is my T-Lone phytech GitHub handle, so you could find this, clone it, and try it out yourself. So what is going on here? Let's navigate in there. Oop. All right. So the really important stuff. I'm gonna talk about this in a second. You notice that I added this distro directory in the conf directory. Layer.conf hasn't changed, so I didn't touch that like I mentioned before. But notice here that my recipes example is now recipes kernel, and it's because I'm targeting kernel, and this is the convention for Linux kernel. The package that's the direct dependency of kernel is Linux, and then Here we have the name of the package. So in this case, if I actually find this here, we can see that this is the actual recipe provided in MetaPhyTech. I am just appending it, and that's what this file extension is. So everything in this file is just tacked on at the end of this, basically. And the reason I can ensure, the way I can ensure that happens is by making sure that the package name is exactly the same, and making sure that the version information is exactly the same. In this case, this should actually reflect the branch of the kernel repository used in the release. But you could also make your BB appends just apply to like any random, whichever recipe that's used. If you just have like a wildcard, like if you don't care which version, you can use a wildcard here. I want this BB append to only apply to the specific recipe, and therefore I specify the whole specific version. Let's take a look at what is going on in there. Now, again, not super complicated. We got a summary description. This is a hack here because I'm not distributing the my software with any licensing, so you can bypass all the license checks with closed. But there are like security audits and various functionality built into the Yocto project that I would recommend making use of as you approach production-ready software. And so following the rules and not just using closed or to bypass things is a good idea. Now, in order for the Yocto project, or especially specifically Open Embedded, to know where various files are going to be found, you're going to have to specify a path essentially for searching these things, and that is stored here in file extra paths, and we can prepend or append to it. And in this case, it's a prepend, so I just have to put a colon at the end, and basically it's saying, hey, in this directory, so in this current working directory here, and oh, actually, I'm sorry. In recipes, so in the location of that file, right? So in here, we're going to be in the files directory. So that's in here, and we know that in there we got the heartbeat d24.patch, and that is the same as the one I got from over here. Yeah, exactly the same. Now, now that it knows a location to look, and then you have to also specify that patch as one being active here in this recipe. You do that by just listing it with this file extension. It just knows, or I don't know what you call this, but this is just telling the whatever that parses this file, bitbake I assume, that this is a local file and to grab it. Oftentimes the source URI will just contain a URL, so you can do local files like so. Now, with that file, with the patch already appended into source URI, bitbake is actually just intelligent enough to know that .patch files should just get applied. And there is a do patch task inherited from Open Embedded, so we can leverage that, and that's why this recipe is very, very simple. So we're basically just specifying where to look and then which file to apply, and bitbake will handle the rest when it comes to modifying our Linux kernel. One thing to note, I do have the patch tracked here in the meta layer. That's typical. That's a lot of meta layers do that. You wouldn't want to version control source code, but patches are typically okay. Now, let's talk a little bit about the custom distro. We're going to navigate back to. So layer.conf didn't change at all. Distro. So basically, I am setting up this new distribution configuration. Let's take a look at it. We are essentially just requiring, this is very similar to include, however, require forces the inclusion to be required. So if this isn't present, you'll throw an error. I think bitbake, if you use include, it may or may not include it, and if it doesn't, you won't get an error. So I do require. So we're basically just going to tack on our changes on top of the existing Arago distro. We're going to rename it to Heart Arago. This is the Heartbeat Arago. So essentially, once we boot up, it's the same software, but we're going to have a default heartbeat on D24. And then I also, just for good measure, stuck this extra line in here. So this image install append variable allows us to add more functionality into our disk image. This is a package that that is provided by a recipe here in the default BSP, but is not included in the TISDK default image by default. So what do I mean by that? We can take a look in the deploy directory and the TISDK default image manifest. And in here we have a manifest of every package that's included in the BSP. And we just do a quick search for NTP date, and we see that is not present. However, I do know that this NTP date utility is actually provided by the NTP package. So certain packages can also install multiple utilities, so that's another thing to note. And this will just take a second to run. Yeah, there we go. So NTP date would get provided by here. We could take a recipe, take a look at this recipe and see how that's done. Just take my word for it. You could do that in your own time, I think. So now, with my meta layer in place, so note, because my preferred Linux kernel provider for TISDK default image is gonna be Linux TI, this is actually gonna apply already, as is. We just have to enable the meta layer. And I'll show you how to do that in a second. Right now, this meta layer is just residing in the sources directory, but it's not actually active. So once we enable the meta layer, this would get automatically included. However, remember that our default build configuration, I'm in the wrong spot, builder. Remember that our default build configuration is Arago. So if we want to have the Heart Arago distribution take effect and then have that NTP date utility get included from the NTP recipe, we would have to also change the local configuration to reflect Heart Arago. So now that we've walked through the meta layer and we've talked about where things are coming from, what the goal of this is, it's going to apply some kernel patch, and so also install one user space utility. We can go ahead and enable it. And so let's do that together with bitbake layers again. We can do add layer and then a path to that meta layer, just like this. So now this patch will get automatically applied. We don't have to do anything for that to happen because the BB appends will just automatically apply whenever the version checks out, and because our TISDK default image prefers Linux TI, this will just happen. Now, let's also enable the Heart Arago distribution, and we do that by modifying the local.conf and just changing this here. Oh, I think there's a dash. We can double check. Conf. Yeah, and it has to be this name here. So now we can just go ahead and rebuild our image.
Moments later.
There we go, that completed. So let's take a look at what we built. So right off the bat, we can see here in the build output that our new distribution is taking effect. We should be able to confirm the NTP date utility is now in our manifest. Yep, there it is. And then the only way we can really quickly check if the Linux kernel patch applied is to just boot this image. So I'm going to go ahead and update my SD card with the new resulting image, and we'll just take a look at what that looks like when it's booted up.
A few moments later.
Alrighty, we got that flash. Let's take a look at what's going on when it boots up. So a couple things. We're going to expect the distribution name to be to reflect Heart Arago once we get to the login line. We should expect this user LED to start heartbeat blinking. So there we go. And then we should also see the NTP date utility available in user space.
More moments later.
There we go, and perfect. We see Heartbeat Arago. We even see the version that I had set. That was kind of redundant though, because it was just the same from the Arago conf. And then if we log in, NTP date, perfect. And then using this, how do we use that? Well, I'll just give it a quick example. By default, if you check the system time, it's like 1970, January 1st. Actually, that's not too far off. It's the new year, or just a few days into the new year now. But the year is super off. So we can use MTP date to synchronize our system time with a network time protocol. That's what MTP means. And we can do that here with this, this pool ntp.org URL. And this will just synchronize the system time, and then it'll be very precise. Oops. Now it is today's date in UTC time, just in case that throws you, because I'm on the Pacific coast. So anyway, that is effectively how we modify the BSP and create a custom Linux distribution named Heartbeat Arago.
Thanks for joining us post-holiday for video 9. And we have one left, so we will see you tomorrow for the final video in the series.